length, angular speed, and linear speed. Okay, arc length. Arc length is defined as the amount, arc being part of a circle, the amount of a circle, let's say from here to here, right? So this would be the arc length, and we're going to call that arc length S. Now, arc lengths are created by central angles. So if I was to connect this to the center of the circle, right, that would make this a central angle. There's going to be some theta based on the radius, right? So the larger the radius, the larger the arc, because the bigger the circle, right? And the larger the angle, the larger the arc length too. Now, when we measure in degrees, it means we're talking about fractions of the circumference. That is, if we think about this carefully, this arc length is a certain fraction of the circumference of the circle. This central angle is a certain fraction of, and in the case of degrees, of all the way around, which is theta over 360 degrees. So if this arc length, if this central angle is equal to 360 degrees, it would be equal to the circumference. That is 360 over 3/60ths. So when we talk about arc length, it's some fraction out of 360 when we're talking degrees, if this is in degrees, of the circumference. So if we knew that theta was equal to 60 degrees, and we knew that the radius was, say, equal to 3, right? Then we know that the arc length would be equal to 60 3/60ths times 2 times pi times 3. Now 60 3/60ths is 1/6, and I've done this pretty cunningly, right? So 2 times 3 is 6 pi. So in that case, it would be pi, and let's say that this was meters, because I actually should have units, pi meters, or right around 3.14 meters would be the arc length. Now, this is what happens if it's degrees. What if it's radians? Well, it's the same principle. Let's say that we had a central angle that was 2 radians, right? Then radians, well, 1 revolution in a radian, that is once around when we're talking radians, is 2 pi, right? So we're talking about the fraction would be 2 radians out of a possible 2 pi times the circumference. Same idea, except we're dividing by 2 pi, because that's once around, would be the arc length. Now what's convenient here is the 2 pi's cancel out, so it turns out that this is just 2 times whatever the radius is. So let's say the radius was 3 meters again, right? Then we just plug in a 3. So this would be 2 times 3, or 6 meters, okay? This means when we're talking radians, because we just have the angle, we don't need to worry about the 2 pi's. In radians, this is what the arc length would be, versus in degrees, this is what the arc length would be, okay? All right, now we're going to apply this. Angular speed. Angular speed, have you ever heard of a tachometer, or a tach, right? Sometimes how it's abbreviated. It measures something called RPMs. In fact, how fast the engine is turning. Typically, if you look on there, it'll say times 1,000. So if it says 1, that means it's 1,000 RPMs, 2, 2,000 RPMs, and so on. This means, or is short for, revolutions per minute. Revolutions per minute, if we abbreviate, right? This is a revolution would be once around, okay? And this is considered to be an angular speed. And this is not a W, it is an omega, which stands for angular speed. So an angular speed is how fast something is spinning. Now, angular speed is independent of the radius. I think you'd agree that this thing has a big radius and this thing has a small radius. But if it's spinning, it doesn't matter how big it is, it matters how fast it's spinning. So if you're talking about this thing turning, right, let's say that this thing is going 1 revolution per second, and this was going 1 revolution per second. These are both going to have the same angular velocity, right? Now, this is not to be confused with something called the linear speed. That is, if you were to look at a point on the radius here, it would mean that this would be going slower than this. Now, if you think about it, this is going to have a smaller circumference because it has a smaller radius, which means it takes 1 second to go around once. This takes 1 second to go around once too, but this one has to go farther, okay? And this leads us to something called linear speed. Now, this is sometimes called tangential velocity. Technically, this particle, whatever this point on the surface, has a tangent line velocity, v sub t. Now, velocity's has direction, so it's going that way at that instant. A little bit later, it could be going the same thing, but it'd be pointed a different way, which is why we talk about linear speed. It's just how fast around the thing is going. Now, remember, velocity or speed, so technically speed is the absolute value of velocity because speed doesn't care about direction. This is a good thing to remember, especially for physics, is the change in distance over the change in time. Now, conveniently enough, if we know how far it's traveled, right, that would be s, the arc length, because if you think about it, if this thing goes from here to here, that's going to be a certain arc length, right? And we know how long it takes to do that, then we should be able to figure out what the speed is. So this would lead us to theta r over t, right? So how does that work? Well, for that, we'd need to know a radius. So let's say we have a radius of 5 meters, right? We'd need to know an angle that it travels. Now, here's where the fun begins. What if instead of that, they told us it was going 3 pi radians per second? That is per 1 second. Well, this is kind of convenient because this is an angle, right? And it's going that fast per second. So it turns out that we could use theta over t, because that's the angle over seconds, right? So we could use omega times r2 to get the speed. So this theta over t is the amount of angle, 3 pi radians, in an amount of time, times the radius, or omega times r. So 3 pi radians per second times 5 meters would be 15 pi meters per second. Sorry, get rid of that other line, looks confusing. Now 15 pi, it'd be 15 times about 3.14. So this is approximately 45 meters per second. Key takeaway, if you want to find the angular speed, or we'll sometimes just call it the velocity, it's equal to omega r, which is simply the arc length, or the angular velocity, times the radius of the circle. This does mean that the particle is if the radius increases, this angular velocity, the angular speed is going to increase also, which makes sense because the bigger circle has more distance to travel. Okay, and that's all we're going to talk about